All right, guys, the final installment of verifying, establishing, proving trigonometric identities. Pretty much the last two videos, I normally don't teach that when I teach a college course. I don't teach, here's an expression, simplify it. That can be challenging. I mean, how do you know when you're done simplifying? That can be tricky. We just dive straight into what I'm about to do in this video, which is here's an actual equation, here's an identity, all right, and you have to prove that it's true. So I think, it can be challenging, but you know where you're going. So I'm going to give you one expression equals another expression. You're going to start with one side, manipulate it until it equals the other side. And there are a bunch of tricks along the way. Once again, the difficult part is the algebra, not the trig substitutions. You've pretty much mastered that at this point. You're not even proficient. You've mastered the substitutions at this point. So once again, in the notes you see this. You're going to start with one side of an equation. You're going to use basic identities, a lot of algebraic manipulation. That's the tricky part. Simplifying, factoring, distributive property, finding a common denominator, etc. And then you're going to arrive at the other side. Okay, so here are a few guidelines. So one is start with the more complicated side. Okay, if you have a sum or a difference, there are two terms and you're trying to go to one term, start with the two terms and then go to the one term. The sums or differences that you have, rewrite them as a single quotient or a single fraction. So if you have term plus or minus term, build one term out of that, and we're going to see that at least twice today, and you've seen that in the past. Sometimes may help. That's where you got to be careful. Sometimes if you're like, I don't even know where to go with this, you can rewrite all terms and everything, every expression in terms of sines and cosines. Not always the easiest thing to do, and there are problems where factoring out a term is actually the first step, but sometimes rewriting everything in terms of sines and cosines helps, and you've seen that. And then the most important thing, I think, is keep your goal in mind. You're given two expressions. You're starting with one expression and you're working your way toward the other. So sometimes you do one step, you do two steps, you look at it and you're like, I'm not sure where to go next. That's okay. Look at where you're going, and sometimes I can, okay, the answer is in terms of cosine. I need to write everything in terms of cosine. So knowing where you're going helps. So hopefully you have enough space on the actual pages that I gave you. We're going to do 6 examples together. Have lots of space, guys. And remember, you have to give a reason. All right, I'm looking at some of your work that you're posting and some of the work that you're presenting, and I'm still seeing problems where not a single word is written anywhere. That's going to cost a lot of points on quizzes and tests. So make sure, be careful. Don't just go out and watch some YouTube video somewhere or some Khan Academy video or some tutor. That's all good stuff, but remember, this is very particular to my class or Miss Bukowski's class or whoever your instructor or professor is in college. Different teachers and instructors have different expectations for this. Okay, so let's begin the process. All right, so here's what I want you guys to see. I'm going to use 2 different methods. Some of you have been doing one in class, some of you have been doing the other. So I'm going to do number 1, basically using the exact same method I've used in class so far, and then I'll alternate and show you different ways of organizing your thoughts. Virtually the same proof, just the order in which it's written is a little different. Okay, so here we go. Like always, pick one side. Which side's more complicated? Certainly the 2 terms being added is more complicated than a simple product. So I'm going to start with tangent of x plus cotangent of x. And in this problem, okay, I see 2 terms, not sure how to combine those. I'm going to rewrite everything in terms of sine and cosine. So tangent is sine of x over cosine of x. Cotangent is cosine of x over sine of x. Don't forget to write your reason. So how do I know that this expression is equivalent to the original? That is, I used both quotient identities. And there are actually two of them. All right, now, and we've seen this before. So now, okay, if the only way I'm going to go from adding two fractions to one fraction is to find a common denominator. So I'm going to multiply the denominator and numerator of the first fraction by sine of x. So that's going to give me sine squared of x over cosine of x times sine of x. And I'm going to multiply the top and bottom, the numerator and denominator of the second fraction, by cosine of x. So that's going to give me cosine squared of x over cosine of x sine of x. So all I've done there is built two fractions that have LCDs. Okay? So now I have a fraction plus a fraction. They have the same denominator. So I'm going to add the two fractions. And this is how I bridge the gap between two terms and one term. Okay, this is where 8th grade, 9th grade, 10th grade is so important. When I add fractions, the denominator does not change. Once I have the same denominator, something out of this plus something out of that, you add the numerators. You do not change the denominator. And that's just simplifying. That's just adding. So I simplified, or simplify, or simplifying. Don't worry about all that. Now, so once again, the easy part, always making the substitutions using the identities. That's always the easy part. So sine squared of x plus cosine squared of x is 1. That's the OG Pythagorean identity. Okay, and now I can see, I'm going to split this. I want to make this clear. All that is factoring. So off to the side, that's literally like saying 1 over 10 is the same as 1 over 2 times 5, which is the same as 1 over 2 times 1 over 5. Okay, so instead of multiplying to simplify, I have actually factored and unsimplified just to be more direct. That's like saying 12 is 4 times 3. That's true. What do I call that? That's called factoring, when you split and write it as a product. Okay, and now I make my last substitution. So 1 over cosine of x is secant of x. 1 over sine of x is cosecant of x. Ooh. Blame that on my low coffee consumption. All right, so I made those two reciprocal identity substitutions, and that is the end of the proof. Okay, virtually the same thing we've been doing all this time, except now you're given an equation. I'm telling you the equation's true. Prove it to me. Okay, so you just have to justify. Start with one side, manipulate until you get to the other side, end of proof. Now, this method, generally, this is not the way I teach it when I teach it at college. Okay, this is a standard way of doing it. Start with one side, rewrite, 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 give a reason all the way down. So this is almost like the geometric proofs you've seen in the past, or basic algebraic proofs from Algebra 1. So now I'm going to show you another way of writing it, which some of you have already done this in class, and I kind of like this method personally. So let's go to example 2. So example 2. Now I'm going to do the same proof, but instead of working my way down, I'm going to work my way horizontally, just straight across the page. So you start with one side, the more complicated side, which in number 2 is pretty obvious. 1 plus tangent of theta over 1 plus cotangent of theta, certainly more complicated. Now, I'm just going to work straight across. So far, nothing different. Now, I don't see any way to simplify this. Rewrite in terms of sine and cosine. So tangent of theta is sine of theta over cosine of theta. 1 plus cotangent of theta, 1 plus cosine of theta over sine of theta. And then I'm going to put the reason under in parentheses. How do I know that this is true? These are my quotient identities. Now, so you rewrite, give a reason. Rewrite, give a reason. Rewrite, give a reason. You just write horizontally all the way across. To me, I prefer this. This is the way I teach it when I teach college courses. So you now know two ways of doing it. And these aren't the only two ways. As long as you are rewriting and justifying, perfectly okay. Now I'm going to build common denominators. I have a fraction plus a number. I need cosine. If I'm going to combine these two terms, if I'm going to combine this term with that term, I need to rewrite 1 as cosine of theta. So cosine of theta over cosine of theta, same as 1, plus sine of theta over cosine of theta. So I'm not changing the second expression. I'm only rewriting the 1 so that I have cosine of theta in the denominator. Same thing on the bottom. I have sine of theta in the denominator. So once again, I'm not going to change the fraction, but I'm going to rewrite 1 in terms of sine. And there it is. Okay. Now, what's the reason for that? That's just building LCDs. That's it. I want to create two fractions with a least common denominator, or you can just write common denominators. That's fine. So now I can actually combine. So now I have cosine of theta plus sine of theta over cosine of theta over sine of theta plus cosine of theta over sine of theta. Not a whole lot going on here. I just simplified. Equals. Now, here's where, and we've done this before, when you divide two fractions, keep, change, flip. So instead of dividing by a fraction, dividing by the denominator, you can multiply by its reciprocal. So I'm going to rewrite this as cosine of theta plus sine of theta over cosine of theta. Oops. Times sine of theta over okay, so if you're looking at this like, what in the world just happened? Here's what we just did. We took A over B divided by C over D, and we rewrote it as A over B times, so instead of dividing by C over D, you're multiplying by D over C. That's what we just did. So my hope is you remember middle school, keep, change, flip, and all those little tricky, goofy ways of saying it. Keep, change, flip. I can't believe I said it. I said it. Oh, shame on me. Okay, so how do I know this is true? This is just simplifying. Instead of dividing by, to me, this is a simpler expression than this. Having a fraction in a fraction, I don't like that. So this is just simplifying, okay? And then equals dot, dot, dot. You just continue the proof down here. So it's like writing an essay. You work from left to right. When you run out of space, you drop down. So now watch this. This is crucial. I have cosine theta plus sine theta, which is the same as sine of theta plus cosine theta. These two factors cancel out. They are the same. I mean, this is A plus B, B plus A. A plus B divided by A plus B just cancels out. So you're left with sine of theta over cosine of theta. I just simplified. Which equals, and then that's where we're trying to go, right? Sine of theta over cosine of theta is tangent of theta. The easy stuff is the trig stuff, reciprocal identity. So if you look at everything we've done in this problem, right? We made a substitution. That was easy. We found the LCD. Looks crazy. Still kind of looks crazy. Still kind of looks crazy. And then at the end, we're like, oh, that's the easy part. So it's all the algebra manipulating in between the trig identities that I think makes this challenging. All right, so there's example 2 in all its glory. Once again, guys, if you didn't know how to manipulate fractions before now, you're going to know it now. All right, let's go to example 3. All right, example 3. I'm going to work this in the traditional way. You can work it straight across your page. Lots of ways to do this. The goal is rewrite, justify, rewrite, justify. And the most common mistake with any of these problems is making huge leaps where you go from one expression to another expression, and there's no way to justify that using one reason. So that's where you have to be careful. All right, so I'm going to start with the more complicated side, which in this case is the sum. So I know that seems weird. A sum, or a difference, is considered more complicated than just one term, which is a fraction. So that language can be a little misleading. So tangent of x plus secant of x equals, before I can combine those two terms, I need to rewrite them in terms of sine and cosine. So sine of x over cosine of x plus secant is 1 over cosine. All right, so you took that quiz, Delta Math, killed a bunch of these just all over the place. All right, so the first reason was the quotient identity. The second reason was the reciprocal identity. So those were my 2 reasons for that. Now, I can combine. So we have sine of x plus 1 over cosine of x. How do I know that? I just simplify it. So you can write simplify, simplifying, simplified, verb, noun, whatever. Now, here's where you have to see where you're going. I'm trying to rewrite this expression that has cosine of x in the denominator as something with 1 minus sine of x. So here's where knowing where I'm going helps. So check this out. I'm going to take this fraction, sine of x plus 1 over cosine of x, and I'm going to multiply the numerator and the denominator by 1 minus sine of x. I'm going to introduce it into the problem. Now, if you're like, why in the world would I do that? Where did that come from? It just fell out of the sky. No, I know where I'm going. So once again, don't lose sight of, that was one of those 4 comments at the beginning. Don't lose sight of where you're going. I'm telling you where you're going, so you can use that knowledge to get there. Okay, so I'm just building in really just a common denominator. I'm trying to take this expression and get 1 minus x in the picture. 1 minus sine of x. Okay? So, now I distribute. Now here's where you can cut some corners here, but I'm going to multiply. I'm going to actually FOIL this out. I say FOIL all the time. I'm going to actually do that. So sine of x times 1, sine of x. Sine of x times negative sine of x is negative sine squared of x. 1 times 1 is 1. 1 times negative sine of x is negative sine of x, all over cosine of x times 1 minus sine of x. All I've done is simplify. Now, I will say this. You're going to be tempted to distribute that cosine of x in the denominator. Don't do that now, because I know I want to leave this 1 minus sine of x. Let me highlight it. I want to leave that alone because that's where I'm going. So I'm going to leave that alone temporarily and see if somehow that cosine of x will cancel out, only because I know where I'm going. So let's simplify this. So sine of x minus sine of x cancels out. I have negative sine squared of x plus 1. I'm going to rewrite that as simply 1 minus sine squared of x all over cosine of x times 1 minus sine of x. Okay, all I've done once again is simplify. Okay? I can kind of see where I'm going. 1 minus sine squared of x, cosine squared of x over cosine of x over, or times 1 minus sine of x. Now that is Pythagorean identity. Now, simplify, and skirt, skirt, and that leaves me cosine of x over 1 minus sine of x. I simplify, and that is the end result in all its glory. So the tricky part of this problem was this right here. Once again, you have to know where you are going, and sometimes you literally just have to drop that in there, okay? And then the reason, that's LCD, all right? You could write, really all we did here was multiply by 1, because 1 minus sine of x over 1 minus sine of x is 1. When you take an expression and you multiply by 1, it doesn't change the expression. So I know a lot of these reasons are just kind of hand waves, but this is forcing you to slow down, justify every step. All right, to the next. I'm going to alternate once again. We did one problem using the vertical method where you work down the page and write reasons. Some of you like to work straight across because that's how we write. I'm going to work this one that way. So start with the more complicated problem, the more complicated expression, which is certainly cosine of x over 1 plus sine of x plus cosine of x over 1 minus sine of x. Now I'm looking at this problem and I'm saying, okay, I have to get a common denominator. So I'm going to build two fractions with a common denominator. I already have 1 plus sine of x. So think of that as one term. That's where you have to be careful. So I'm taking cosine of x over 1 plus sine of x. Okay? And I'm introducing the denominator for the second fraction. So I'm going to multiply top and bottom by 1 minus sine of x, 1 minus sine of x. So once again, what am I doing here? I'm building an LCD, but I'm in essence multiplying top and bottom by 1. Okay, so that's my first fraction. My second fraction already had 1 minus sine of x in the denominator. So I'm going to introduce 1 plus sine of x over 1 plus sine of x. So the reason here is I just built two problems that have an LCD. Okay? Now, I'm going to actually simplify all this. So I am going to distribute here, so I have cosine of x times negative sine of x is negative cosine of x sine of x plus, so there's my plus sign, cosine of x times 1 is cosine of x plus cosine of x times sine of x is cosine of x times sine of x. In the denominator, I have 1 minus sine of x plus sine of x minus sine squared of x. So all I did was take the least common denominator and I FOILed it out. Okay, so all I've done is simplify. You can say distributive property. You can say FOIL. I just multiplied everything out in the numerator, everything out in the denominator. So now, let's see what happens. So I have negative cosine of x sine of x, positive cosine of x sine of x. So those two terms cancel out. And the numerator becomes cosine of x plus cosine of x, which is 2 cosine of x. So that's my numerator. My sine of x's cancel out. That leaves me 1 minus sine squared of x. So 1 minus sine squared of x. And this is definitely just simplifying. All right, so anytime I see those squares, 1 minus cosine squared of x is 1 minus sine squared of x is cosine squared of x. That is Pythagorean identity substitution. And then I simplify. Cosine of x, 1 on top, 1 on bottom, cancels, and that leaves me a factor of 2 on top and a factor of cosine of x on the bottom, still simplifying. And then, now you can just flip. I'm gonna split this. You don't have to include this step, but I do want to make it clear. You can go straight from 2 over cosine of x. Cosine of x in the denominator becomes secant of x in the numerator. So you do not have to include this factor step if you don't want to. But just to make it clear, 2 times 1 over cosine of x is 2 over cosine of x. 1 over cosine of x, if we're going to be pure, 1 over cosine of x is secant of x. That's my reciprocal. Identity. Once again, you can go straight from 2 over cosine of x to secant of x, reciprocal identity. But I just want to show you a little bit more of what's going on there. So the hardest part in this problem was knowing that 1 plus sine of x is considered one factor, 1 plus sine of x. Put it in parentheses. 1 minus sine of x is considered a different factor. So you have factor 1, factor 2. You need both of those in your denominators before you can add these fractions. All right. That is example 4 to example 5. As continuing to alternate, here we go. I'm going to work vertically down, so I have 1 over tangent of x plus secant of x. Don't know how to combine those, not a lot going on there. Rewrite. Tangent of x is sine of x over cosine of x. Secant of x is 1 over cosine of x. So that is both my quotient identity and my reciprocal identity. Okay? Go ahead and simplify. Both of these, what the word? So both of these fractions have cosine in the denominator. So this is sine of x plus 1 over cosine of x. So all I did was combine like terms, or add the fractions, simplify. Now, keep change, flip. So we have 1 divided by this fraction is the same as multiplying by its reciprocal. So we are rewriting a fraction and a fraction as a product, simplifying. And just like that, look where we're going. There it is. 1 plus anything is anything. 1 plus a value is the value. And all we did was simplify. So, once again, the easiest part of the proof was the trig substitution. The trig identities being substituted in. Everything after that was a whole lot of knowing to add these two fractions since they have a common denominator, knowing that now that we have a fraction within a fraction to rewrite it as a product, and then it worked itself out. All right, one last example, and I'll use the straight across the page horizontal method. All right, guys, so this is our first instance of what you're about to see. We have a fraction equals a fraction, and then this is where, for the first time, I'm actually going to start with the right side. Now, I'm going to start with the right side because, to me, cosecant is a messier expression than something in terms of sine. So, and you can start with either side anytime. You can always choose, I'm going to start with the left side. I'm going to start with the right side. Completely arbitrary. As long as you start with one side, manipulate completely until you get the other side. So, cosecant of theta plus 1 over cosecant of theta minus 1. I'm going to rewrite in terms of sine because I know where I'm going. I know ultimately I need to have an expression in terms of sine. So there we are. So, reciprocal identity is all I've used so far. We've seen this trick at this point. Now I need to build two fractions with. So I'm going to rewrite one in terms of sine, which is sine over sine, sine of theta over sine of theta, 1 over sine of theta minus sine of theta over sine of theta. So all I did was build two fractions with least common denominators. Okay? Then I'm going to actually simplify. So the numerator becomes 1 plus sine of theta over my sine of theta. The denominator becomes 1 minus sine of theta over sine of theta. All I did was simplify. Okay, and you know where we're going. Now that we have a big old fraction divided by a big old fraction, we're just going to keep change flip. Oh, I said it again. Guys, the shame knows no boundary. So 1 plus sine of theta over sine of theta times the reciprocal of the denominator, sine of theta, over 1 minus sine of theta. Now, if you need to pause it and go, what just happened? You really need to make sense of that. Hopefully you can see what just happened, but if not, I understand. So what did I do? I simplified. Fraction divided by a fraction is a fraction times its reciprocal, the number we're dividing by. My sine of thetas cancel out, and we are left with 1 plus sine of theta over 1 minus sine of theta. And if I'm not mistaken, that is where we wanted to go. So we simplified. Okay, so we actually started with, so we started with the right side, and we ended up with the left side. Only one trig identity was used. Everything else was algebra, 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 bag of tricks. So guys, I know this is difficult, but be careful that you don't just say, this is difficult and cross your arms. The only way to do these problems, take a problem that you've already seen worked out and work it, rework it, rework it. There are only so many of these, meaning once you've done the problems in these next 3 handouts, you have literally done every single problem that you could ever be given on a quiz or a test. So work a problem, check your solutions, work a problem, check your solutions, and just know that you will exhaust every possible problem. So, and use the solutions as a guide. No worries, all right? This is old school. This is the kind of thing that you learn by cranking and cranking and cranking and cranking, not watching. You can watch videos, you can watch this all day long until you write it down, until you actually physically put your hand on the paper and write it. It won't stick. So definitely grind these problems out, check your solutions, And you got this. Keep working hard. Finish strong. I will see y'all in class. Be ready with those presentations, y'all.